Okay, welcome to the lecture on uh, how to complete the final project. The really great thing about this final project is hopefully you will also be learning the content as you complete the requirements for the final project. So I'm going to bring you through. For the final project, you have a workbook that looks very similar to this one. It has all of the data already in it, and then you'll see on the bottom it'll say single sample, independent, paired, and chi-squared. And where you're going to find that is you're going to come here, let's see here, go to Canvas, and when you go to Canvas you're going to go to QBA 2302, let's see here, we're going to go to Final Project. And when you go to Final Project, we're going to come to Datasets. And right down here, you will see a list of all the different datasets that you have to choose from. You can work with a group of up to 3 people to complete this, so you don't have to do this by yourself. But I do want you to learn all of the content yourself, go through the videos, make sure that you thoroughly understand it. The more you understand this, the better you'll do on the final exam as well. So let's go back to the final project, and we're going to get started with the single sample. Right here you're going to see what this sample data does for you. It's a nice little yellow thing that says, hey, you know what, here's what this data is. And just so that you guys can see the actual data, let's see here, where do I have it? I think I have it here somewhere. Yes, I have right here. This data allows you to compare the average salaries from Atlanta and the population average salaries of the whole nation. Okay, so right down here we have the base pay data. So we've got all of the Atlanta salaries. Okay, and then we also have the salaries for the entire nation as well. There's a couple different ways that you could do this. There's a couple different ways that you could do this, and let's see here. These are the salaries for a particular job title in each particular city. Okay, so I'm going to go, let's see here, dimension, median, let's see, metro. What do I want? I want the national. So I'm going to do national, and I am just going to copy all of these salaries for the entire nation, Control C, and then I'm going to bring them over here. And so you'll notice that right now you have the national salaries. It's already set up for you. You've got the population mean, you've got the population standard deviation. That's great. Sometimes you'll have it like that. Sometimes you'll have it like this, where you have the national data all right here, and then you have the the sample data, or the subpopulation data right there. And so if you have the national data that's already summed up right there, great. If not, you might need to do a quick, equals average, and find the average of your data. Okay, and so we've got average. And so we've got right there, you'll notice it's the exact same thing. And then we've got the standard deviation equals standard deviation of the population. And you'll notice, okay, great, which I think, let's see, did I take a sample? Yeah, this is set up as a sample. The reason why is I pulled this from a pivot table, and when the pivot table did it as a sample. So for you, this should be the population data, but once again, it's just a sample pulled from the population. So we ran it as a sample standard deviation. Where you should run it, basically, this is well, really, it would have been fine if you would have ran it as a sample or as a population, but just make sure that you clearly say, hey, this is what I'm using Either formula probably, really could work just fine. And as, you can justify both of them as being accurate. So just make sure that you document in here the correct value that you've calculated for that. So we're going to come over here and let's see here. So we've got the population data, the sample data, and we're going to run a fun little, we're going to delete this. We're going to run some information. And it is descriptive statistics. So I'm going to come right over here and I'm going to go data. And I'm going to do data analysis. You'll notice right up here. And I'm going to click on something that says descriptive statistics. This is pretty much the first thing that we're doing. We're screening the data that we have. And so we've got descriptive statistics. And I want the descriptive statistics on Atlanta. I'm going to do something really quick because... let's see here. Insert, shift cells down. The reason why I'm doing this is because I already ran the descriptive statistics once, and then I put in the sample mean and the sample standard deviation. And so I don't want the sample mean and the sample standard deviation to be considered in there. So I'm going to do, once again, data analysis, descriptive statistics, press OK, and then I'm going to do the input range. And I'm going to start with the title. Notice before when I started with the title and it didn't have that in there, it just skipped over those cells. But so I've got the input range, I highlighted all of that. And then the output range, where do I want this? I want this to go right here. And you'll notice it says descriptive statistics for data analysis tool. Just put it right under there. And then I want the summary statistics and the confidence level for the mean. Now, the confidence level, this is really important because you need to decide right now, what is your alpha going to be? How confident do you want to be about your test, about your results? Do you want to be 95% confident? Do you want to be 90% confident? What do you want your alpha to be? So for this, I think I want to have an alpha of, let's see, I think I'm going to do 0.05, an alpha of 0.05, so I'm going to press OK. So I set the confidence level for 95% if I have an alpha of 0.05. There's a problem. Let's see here. Output range. Oops, I accidentally told it to go into too many different places. So we're going to press OK. And I just want to make sure that... Yep. So now I have the Atlanta salaries, and I've got the mean, I've got the standard error, the median, and it gives me everything that I need to know. And right away, so this originally was blank, and so now I'm going to take this and I'm going to say, okay, Control C, and then I'm going to press Control V, and then sample standard deviation. Let's see here, standard deviation, Control C. And then Control V, and we're good to go. So let's keep moving here. Now that we have our descriptive statistics, we're going to come back to this several times, but we'll just leave it here for right now. Okay, so let's come over here and we have to make a few decisions. First of all, remember what I said about the declared alpha. What is it that I want it to be? And so I'm going to say, okay, I want my alpha to be 0.05. And so I've got my alpha of 0.05 because I only want a 5% chance that I say that there's a difference, but there really isn't a difference. And then the next question is what's the degrees of freedom? The degrees of freedom, once again, is the number in the sample minus 1. So we come down here and we see, oh, wonderful. Descriptive statistics gives us a count. And so we've got the number in the sample minus 1. So the degrees of freedom is going to be 83. And I actually have everything all ready typed out in here. I just have to make it into black font. So if you're wondering why it's going so fast. So tail. The next question that I have is this an upper tail, a lower tail, or is this a two-tail? Is there a reason why I think that Atlanta salaries are going to be higher or lower than the national salaries? Or are they just going to be different? And the truth is I have no clue. So if I have no clue if it's going to be higher or lower, I'm just going to say, you know what, I think it's just going to be different. So I'm going to say it's going to be a two-tailed test. Then next, am I going to do a z-score? What is my test statistic going to be? Z, t, or chi-squared? And I'm going to go with z. And the reason why I'm going to go with z is because I know the population standard deviation. If I don't know the population standard deviation, then I'm going to go with a t. But I do know the population standard deviation, so therefore I'm going to go with a z. And what is the population standard deviation? Well, I'm just going to do equals, and then I'm going to come over here, and I'm going to put, okay, give me that. So it gives me the population standard deviation, and then the population mean, tab, control Z. Let's give me the population mean. Once again, just press equals, come over here, and give me the population mean, or type it in, either way. You can also just come over here and say, oh, this is great. We're going to control C, population mean, control V, and then standard deviation, control C, and then control V, except it's going to be 9, and then this is going to be 7. Okay, and then once again, sample size, we've got a sample size of 84. We know that from earlier. And then the sample mean, once again, just come over here. We've got the sample mean right here, control C. And then we're going to, paste it in right there. And then the sample standard deviation is right down here. And so we'll just put it in right there. And I'm going to shorten that to just... There we go. So we've got our basic descriptive data here, and so now we kind of want to know, what is it that we want to know? Research question. What is it that we want to know? And in order to do this, you really have to know the purpose of this type of test. So if you come down here, you'll see all these different reference things, and if you want to know what type of research question to ask, come over here to the purposes, and we are going to see, these are the different things that you can do with a single sample test. You can determine if a sample is representative of a population. You can compare a sample to a population to determine if there's a difference. Determine if a population parameter may have changed. And no matter what, it's just always comparing means. So what I'm looking at is I'm thinking, hey, I think it's comparing a sample to a population to determine if a difference exists. So I'm just going to copy this, and I'm going to come back over here, and I'm going to go right here, and I am going to paste it right in here. And so I'm going to say, for my research question, I'm going to say, are the average salaries in Atlanta different from the average salaries of the nation? And that's my research question. I just took the purpose and I made it into my research question. And so once again, the purpose of running the test is to compare a sample of Atlanta salaries to the population average salaries to determine if a difference exists. So the research question is basically very reflective of the purpose. So I put the purpose right there, I put the research question right there, and then my anticipated outcome is we anticipate that there will be a difference between Atlanta and between the average salaries of Atlanta and the average salaries of the nation. Okay, so that is the anticipated outcome. And then the next thing that we need to do is we need to determine the critical value. So the critical value, in order to determine the critical value, I want you guys to go go back here to Canvas, and we're going to go to Pages, and we're going to go to Unit 4. And when you go to Unit 4, go to Printable Resources, and we're going to go to the Critical Values diagram. And when it pulls up the critical values diagram, you're going to see this right here. And we have, because we're using a z-score, we can use this diagram. And this diagram, we're looking at it and we're like, okay, we've got an alpha of 0.05, and we have is it a two-tailed test, an upper tail test, or a lower tail test? And we're running a two-tailed test. Okay, so because we're running a two-tailed test, we're going to come right here and we're going to see, okay, we've got an alpha of 0.05, and therefore the critical values are going to be plus or minus 1.96. Plus or minus 1.96. And what this does for us is, make sure that you watch the video on this because it goes much more in depth, but it puts half of the region of, or half of the probability of type 1 error in the right hand side and half of the probability of type 1 error in the left hand side to give you a total probability of type 1 error of 5%. So the critical value is plus or minus 1.96. Plus or minus 1.96, so I'm going to put the critical values right here. And for two-tailed tests, there are two critical values. For one-tailed test, there's only one critical value. The next thing that we're going to do is we are going to check the assumptions. This is something that is new. We have not checked assumptions in anything else, but this is very important. And the reason why is because in order to make sure that your interpretations are correct, your assumptions have to be correct. The test has to meet the assumptions. So I'm going to look at these assumptions. And once again, you go back to the single sample reference and it says, okay, here's the assumptions. The first assumption is that there's one dependent variable that's measured at the continuous level. The next assumption is that all the data points are independent. The third is that there's no significant outliers in the independent variable in terms of the dependent variable. And then last, the dependent variable should be approximately normally distributed for each group, or really should be normally distributed. Let's just leave it like that. So we're going to look at that. So assumption 1, what is the one dependent variable? The one dependent variable, we're looking at this, the one dependent variable which is dependent on the location. So the independent variable is the location. So let's put this right here, independent location, and dependent variable is going to be salaries. Okay, so salaries are dependent on location. The average salary is based on the national salary. The average salary is based on the fact that it's in Atlanta. And so there is one dependent variable, and I'm going to just put that in black. There we go. There is one dependent variable, which is salaries, which is a continuous variable that is dependent on the independent variable of location. And sorry, I'm going to just zoom in a little bit more. That way you can see everything. One dependent variable, salaries, and then one independent variable, location. Okay. Next. Assumption 2 is each individual observation in the independent variable is each individual observation in the sample independent from all the other observations. And basically what we're saying is, are all of these independent? Or is this one dependent on this? Is this one dependent on this? And we know that every single last one of these is completely separate from each other. So therefore, we're going to put all of the salaries are independent of each other. Next, we're going to say the assumption 3 is there's no significant outliers in the independent variable. Okay. So there's no significant outliers in the independent variable. So what we're going to do in order to determine this is we're going to make a box and whisker chart. So we're going to highlight all of this, and then we're going to go to Insert, and then we're going to click on this fun little thing that looks like a histogram, and it should come down here, and it says Box and Whisker. So now we have average salaries in Atlanta. Okay, so we've got average salaries in Atlanta, and I'm just gonna, what I just did is I cut it, and I'm going to put it in a slightly different location. I'm gonna bring it right over here, and I'm gonna put it right here, which is to the right hand side of everything that we're doing. So we've got the average salaries in Atlanta, and this is the box and whisker plot showing us that. And the next thing that I'm going to do is I'm going to double click on this, which is going to bring up chart design. And when I get to chart design, I'm going to add chart elements, and it gives me all these wonderful options of what it is that I want. And it says data labels, and I want data labels, and I want data labels to the left. Data labels to the left. And so now that I have this, I'm going to just take it straight from this, and I'm going to put it right over here, and I want these values. So what is the max value that is not an outlier? And that's 120,207. Okay, and then Q3, what is Q3? That's going to be right there. We're going to put it right there. Okay. And then what is the median? Notice the median is this blue line right here, which is going to be 58,677. And then Q1 is going to be right down here, 41,611. Okay. And then what is the minimum value that is not an outlier? And that's going to be 23,527. And then what's the mean? It's going to be that X right there, which is 61,648. And then are there any outliers above? If there's outliers above, there would be asterisks all up here, but there are no outliers above. And then also, are there any outliers below? And the answer is no. So go ahead and fill that in right there, and that'll be really great to have that information. So that way you know, did it violate the assumption of having extreme values? And what we determined is that no, it did not. There are no significant outliers, so that's really good. And then next we need to have the dependent variable should be approximately normally distributed. Once again, I accidentally have for the dependent variable should be approximately normally distributed. Okay, so we're going to come right over here, and we're going to make a histogram. So once again, I'm just going to highlight it, and then I'm going to do insert, histogram, and I'm going to say average Atlanta salaries, and I'm going to put it right next to the other chart, and you'll see, okay, I backed up really far just so you could see everything. But I'm going to put the histogram right next to the bar chart, which is going to be right over on the right hand side. So histogram is going to be right there. And looking at this, it's really great. It looks pretty normal. You know, it's a little skewed, but you know, for the most part, it looks pretty normal. And there's one more piece of information that we need to look at, and that's over here in the descriptives. You notice the kurtosis and the skewness. Both of these are under 1. So because both the skewness and the kurtosis are under 1, and because the histogram looks good, we know that it's good. Okay, so you notice it says skewness. I put in there skewness equals 0.433, and then kurtosis equals 0.3466, and then I'm going to put a little bit more information in here, and I'm going to say because both the skewness and kurtosis are less than 1 standard deviation away from a perfectly normal distribution, we conclude that the dependent variable is normally distributed. Now, what I just said there is less than 1 standard deviation. The skewness and the kurtosis, those values is how many standard deviations away the skewness is from being not skewed at all. Okay, and that's how many standard deviations the kurtosis is away from not being leptokurtic or platykurtic at all. So I put this in there, and I put the actual values in there, and this is pretty much how you should write it. Okay, and you can literally almost copy it word for word. A little bit later, you're going to see, oh, he does have leptokurtic data, or he does have, positively or negatively skewed data. And if we do have positively, negatively, or negatively skewed data, then we'll have to note that and say, hey, this should be noted, a transformation should be done, but we're not going to do a transformation at this time. Note any issues. There are no violations of any assumptions, so we can proceed with the hypothesis testing. So the next thing that we're going to do is we are going to write the null hypothesis and the alternative hypothesis. And a really great resource for you, if you come right over here to the single sample reference, you'll notice, okay, there is a wonderful reference that says, okay, this is how you should write a single sample hypothesis, a null and an alternative, and you can read through that a little bit more. But in this particular case, what we are anticipating is that the null hypothesis is saying that there is no difference between the average salaries of Atlanta and the average salaries of the United States. Okay, and so the way that you would write that is mu, and you could just do mu, or you could do mu sub a for Atlanta, subscript. Mu sub a equals 59,456.67. What is that number, that 59,456? That is the average salary for the nation. That's the national average salary. And so the null hypothesis says there is no difference between the average national salary and the average national salary and the average salary of Atlanta. Conversely, the alternative hypothesis says there is a difference. In other words, the average salary of Atlanta is not equal to the average salary of the United States. So this one says they are equal. This one says they're not equal. So the null hypothesis says there is no difference. The alternative hypothesis says there is a difference. And then right over here, what would be really great is if you were to write it in words, there is no difference between the average salaries of Atlanta and the nation. And then you can literally just copy this, Control C, Control V. There is a difference between the average salaries of Atlanta and the nation. So we've got the alternative and we've got the null hypotheses, and then the next thing that we're going to do is the test critical value, okay, which we already have that. Let's see here, the critical value plus or minus 1.96. So let's just put it right there again, plus or minus 1.96. We know the tail, we know everything about it, and now what we need to do is we need to make the decision rules, okay? And then also right here, just a little bit of information. Let's see here. This is just some information for you. Just remember, if a calculated value is beyond, so when we go in and we calculate the actual calculated values, if the calculated value is beyond the test critical values, then we'll reject the idea that there's no difference between the population and sample, and determine that there is a possibility that there's a difference. Okay, and so we're going to kind of get into that right here. So the reject decision rule, okay, which the reject decision rule, we are going to reject the null hypothesis if zcalc, which, are we using z? Yes, we are using z. Why are we using z? Because we have a population standard deviation. If zcalc is less than 1.96, or if it is greater than 1.96. So if zcalc is less than 1.9 or negative 1.96, or if it's greater than 1.96, we're going to reject the null hypothesis. Okay. And just take a minute and write a little bit more information about that. And you can say if the calculated value of the average Atlanta salaries has a z-value, like I just said, of less than 1.96 or greater than 1.96, then we will be at least 95% confident that there is a difference between the sample and the population. Why is it 95% confident? The reason why it's 95% confident is because there is the reason why we're 95% confident is because the alpha is 0.05. So therefore, the confidence that we have is 95%. Okay. And then fail to reject the decision rule. We fail to reject the null hypothesis, basically the opposite of this, if zcalc is between negative 1.96 and 1.96 inclusive. So greater than or equal to and less than or equal to. And then once again, same thing. If the calculated value of the average Atlanta, I literally just copied and pasted it and just adjusted it a little bit, then we'll be able to determine that there is a difference between the sample and the population. That there is, right here it should say that there is a sample, that there is a difference, and this one should say that there is not a difference. Okay, so now let's actually do a little bit of math. Okay, so test calc value. Test calc value. In order to calculate the test statistic, there are several ways that you can do this. You can actually take the population mean and the population standard error, and you can run it all like this. Or I have actually set up over here some great little formulas for you. And we're just going to put in the sample mean, the sample standard deviation, the sample size, the population mean, and the population standard deviation. And I'm just going to put all that in for you right there. And when we do this, what's going to happen, and I'm going to, let's see here. When you put in this information, there's some formulas that run, okay? And the formulas that run basically use some various, it's just really easy to mess these up, and that's the reason why I'm not having you do it. But you could actually do it by doing z-test or t-distribution. There's different formulas. There's lots of different formulas. But as of right now, I'm just going to have you use this fun little calculator. There's so many different calculators that literally you just put it in, and as long as you know the right things to put in, then you'll be able to run it. And so for this particular situation, I'm just going to have you put it into this fun little calculator. Don't copy and paste. You're going to need to type all of this in. And the reason why you're going to need to type all of it in is because if you copy and paste it wrong, it'll destroy the calculator. And so I don't want you to do that, because then all of a sudden you're going to be like, hey, it's not working. And then that would be very bad. Moving on. Once again, standard error. Yeah. So let's keep moving. So we've got all of the wonderful information right here. We've got the zcalc score. We've got so we've got all that information, and just for kicks and giggles, I'm going to go ahead and show you. So the national salary, 59,456, and the population standard deviation. Now, if I wanted to, I could, like I said, actually run this and do all the calculations by hand. And so in order to do this, what we need to do is find the standard error. Okay, so let's take a look on this fun little formula sheet, and we've got the standard error. Let's see, where is standard error? So we've got the standard error right here, which is the standard deviation divided by the square root of n. So we've got this standard deviation right here, and so we're going to do equals this standard deviation divided by the square root of, remember how many are there? There are 84. So 84. And so this right here is the standard error. The population standard error. So we've got 59,456 with a population standard error of 2,264. So now the question is what is the z-score? Okay, so we've got this information right here, and so now we need to calculate the z-score. So let's take a look once again. Let's calculate the z-score. This is how we calculate the z-score. The z-score is the average of the sample minus the population divided by the standard error. Okay, so we're going to do equals 61,647.75 minus 59,457. Okay, and then we're going to do equals 2,191 divided by the standard error. Okay, and this is not supposed to be currency, general, and you're going to see this right here is the z-score. This right here is the z-score, or you can just come right over here and bada bing bada boom, it is the exact same z-score. So we calculated the z-score by hand right here, the longhand, and so I just did that to show you all. This is the z-score. Okay, it really should say z-calc score. I know why I did that. Z-calc score, or T-calc score. There we go. So that's z-calc score. So coming down here, we are going to Control C, and we're going to put the z-calc score. Oh, it's already right there. Or we can press Control V and just paste just the values, which is 9.67. So there's the calc score. Coming back over here, you'll notice what is the what are the p-values. So what is the probability of this occurring, assuming that there is no difference, assuming that the null hypothesis is true? What is the probability of this occurring? Well, is this a one-tailed test that's upper, one-tailed test that's lower, or is this a two-tailed test? This is a two-tailed test. So you'll notice this is the p-value of a two-tailed test, which is 0.3332. Okay, so coming right down here, we're going to put a p-value of 0.3332. Oops. We're going to put that p-value right there. And so what does that mean? The probability that of having this particular result, assuming the null hypothesis is true, is 0.3332. Okay, so that's the information there, and then test calc value, the sample, or the population, the average, let's see, average salaries in Atlanta are 0.967. standard deviations above the population, the nation. There we go. Statistical significance. What should we say about this? Because the probability of this randomly occurring, assuming the sample is equal to the population, is 0.333. This is greater than the alpha, so we cannot determine if there is a difference between the sample and the population. So there's two ways to test this. You can either compare the alpha level to the p-value, or you can compare the test calc value to the test critical value. So statistical significance. So you could say it like this, or you could say because the probability, because the test calc value, or the z calc value of 0.967 is not beyond the z critical values, it is not statistically significant. To be honest though, you really don't need to do this one right here. The p-value will really suffice, so I'm actually going to just delete this. They both say pretty much the exact same thing, but the p-value is really what you should be using to determine statistical significance. Okay, and then make a hypothesis decision. When you make a hypothesis decision, that's when you are that's when you're using the test calc values. So use the p-values for statistical significance, use the test calc values for the hypothesis decision. Okay, and then you can say right here, make a hypothesis decision. This really should be Control X, Control V, fail to reject the null, or hypothesis. And then this is the explanation. Then the difference score. Basically, we want to know where is this difference. Okay, and there is a difference between the sample and the population of the average sample of $2,036.75. But even though there is that difference, it's still not statistically significant. And then right down here, this tells us that what you need to do. Let's and I like it a lot better like that. The sample mean plus or minus the standard deviation. Okay, so what is the sample mean plus or minus the standard deviation? So let's come over here to the sample mean. And we've got the sample mean right here. And then we've got the standard deviation right here. So we've got equals the mean minus the standard deviation. Then we've got equals the mean plus the standard deviation. Why do I care? Great question. This tells us that these are the values that are within one standard deviation of the mean. So we can assume that each individual value, that 68% of the values will fall within these limits. So what we're going to do is we're going to come down here and we're going to say, what is the sample mean plus or minus the standard deviation? So this is the lower level, or the lower limit of, and upper limit of. Okay, and interpreting that, we're going to say 68% of the observations in the population of the entirety of Atlanta should fall between those two values. Okay. And then last but not least, confidence interval for the sample mean, the mean plus or minus the margin of error. So we've got that right there. So it's 61,647 plus 4,836 plus or minus that. So the confidence interval for the sample mean plus or minus the margin of error. In other words, we are margin of error. We're 95% confident because we've got we with the margin of error, we calculated the margin of error with a 5%. So how do we get the margin of error? That's a great question. So the way that we get the margin of error, let's see here, we're going to come right up here to find the margin of error again, and we're going to pull up this fun sheet. So we've got the margin of error. Let's see, where is the margin of error? Margin of error. Okay, so margin of error. The margin of error is going to be the, here we go. The z-score multiplied by the standard deviation divided by the square root of n. And this right here is z crit, or basically the confidence interval, however confident you want to be, we're going to use that value. So we have a 5, our alpha is 0.05, so we're going to use a z crit, or we're going to use the z-score of 1.96. So we're going to do 1.96 multiplied by the standard error, which is the standard deviation divided by the square root of n. And so we're going to do equals 1.96 multiplied by the standard deviation divided by the square root of 84. Okay, so this right here is the margin of error. I think I did that right. Yeah, that'll do. Square root of 84. So we've got 4,836 and 14 cents. So coming down here, we're going to see once again, well, I guess it rounds up to 15 cents. $4,836.15. So we've got the mean right there, plus or minus the margin of error. So the lower limit is $56,811.60, and the upper limit is $66,483.90. And so how we interpret this is, based on this sample, we are 95% confident that the average of the salaries in Atlanta are between the average salary. The average of the salaries in Atlanta is between $56,811.60 and $66,483.90. And so that tells us how confident we are that that is actually the mean. Okay. Next, we calculate the effect size. And once again, the reason why we care about the effect size is because and I should have kept up on this left-hand side. There's this fun little analogy on this left-hand side. It's an analogy about a fishing trip, right? So when we go on a fishing trip, I don't know if y'all have ever been fishing, but I like fishing. We first say, hey, this is what we're going to be doing when we go fishing. Tell me all about the fishing trip that you're going to take, and the different things that you're going to be packing in your toolbox, so on and so forth. And then when you're like, okay, I'm going to pack these lures, I'm going to use this. I'm going to be measuring it with this particular ruler, and I'm going to be doing all this information. Just tell me about the general information about this trip. Next. It's what are you looking for on your trip? Are you going to be looking for muskie? Are you going to be looking for northern? Are you going to be looking for walleye? What is it that you're going to be looking for? And so that's the research question. Then next, you're going to make sure hey, am I at the right lake before you launch your boat? Check your assumptions. Make sure that you're at the right lake. The reason why that's really important is because if you're at the wrong lake, you're not going to be able to catch the right fish. And you're like, the wrong lake. My favorite place to go fishing in the whole wide world is here. I'm gonna. Okay, so this is my favorite place to go fishing in the whole wide world. It's called Bass Lake, and so you would assume that there are bass in there, which there are. There's also northern. There's also perch, and there used to be some bigger fish, but there's not really that many bigger fish in there anymore. And so when you go fishing there, you might be catching certain types of fish, and one of which would be a bass. This right here is a bass, but you'll notice that that's actually a pretty small bass. That bass right there, it might be about 11 inches long, but you need a bass to be at least 15 inches long in order for you to keep it. Okay, so but in order for you to go fishing for the right type of fish, you need to make sure that you're at the right lake. So make sure that you're at the right lake. Make sure that you are actually looking for what it is that you're actually planning on catching. Next, determine what is considered catching something before you start. Like for instance, if you catch a whole bunch of perch, that's great, but you were really fishing for bass. So if you were fishing for bass, did you really catch anything? No, you didn't catch anything. You caught a whole bunch of perch, and the reason why is because perch bite at everything. So make sure that you've determined before you start, hey, this is what we consider to be catching something. And don't lie and say, hey, I caught something when you really didn't. Okay. Next, the question is you caught something. What did you catch? You need to describe what you caught. Like for instance, right here, we caught something. Great. We caught a bass. It's a smallmouth bass, and this is what we caught. That's really good information. I wanted to know that we caught a smallmouth bass. So then it's like, okay, we did catch something. We really legitimately caught a smallmouth bass. That's wonderful. But where it really comes into play is the effect size. Okay. With the effect size, it's like, okay, you caught a smallmouth bass, but how big is that smallmouth bass? You caught a smallmouth bass, but is it even worth keeping? And so in order to determine that, we're going to come over here and put some information in here. Okay. And so in order to do this, we need the mean of sample 1. So I'm going to come over here and get the mean of sample 1. And I'm going to zoom out just a little bit and show you where I'm going. Okay, so this right here, this is the information on the effect sizes. The effect sizes are right here. And so this is the formula for the effect sizes. It's the mean of the sample minus the mean of the population divided by the standard deviation. Okay? So let's see here. We've got the mean of the population. So equals the mean of... we're going to do ABS absolute, the mean of the sample minus the mean of the population divided by the standard deviation of the population, and that gives us an effect size of 0.105 or 0.106. So we'll do an effect size of 0.106, and I'm going to come right down here and I'm going to put 0.106. Okay, so that's great, 0.106. And let's come over here for a second and take a look at how big this effect size is. Okay, so this says 0.106. If we have a significant result with a small effect size, the actual difference would really not be noticeable without statistical analyses or without a large sample size. Okay, so in other words, you know what? Even if we had a statistically significant difference, the difference would be so small that it would barely even be noticeable. And so you would just write right here the effect size of 0.106 is very small. Even if the results were statistically significant, we would not be able to tell the difference without the use of statistical software or methods. Next, the last thing that you're going to do for the single sample is you're going to write a discussion of the results, providing appropriate inferences and insights in a way that an 8th grader could understand. Just tell me what to take away and how you found how it applies. So just literally you follow this prompt, okay? Follow this prompt, and when you follow this prompt, you're going to get something like this, okay? And you're going to see, okay, what was run? A single sample hypothesis test was conducted to determine the purpose if the average salaries in Atlanta are different than the average salaries in the United States. Literally, you're just telling me exactly what you did, okay? Then, according to our results, let's see here. I just got to zoom out a little bit. According to our results, we are not able to determine the difference in salaries of 2,037 between the United States and Atlanta is actually different. The probability of these results occurring randomly, if the sample is the same as the population, is about 33%. Okay, the large range of possible outcomes contributes to our inability to determine if there is a difference. Okay, notice right over here, it says, what are the results? What is the p-value? So this is the p-value. The probability of it randomly occurring, that's the p-value. And then give insight about possible factors that influences. So basically I said there's a really big standard deviation. Because there's a big standard deviation, that's one of the reasons why we're having issues. Okay. Then talk about the confidence interval and the standard deviation, whichever one's appropriate. They may not both be appropriate. Talk about which one is appropriate. So you've got to have at least one of those two. Okay. We are 95% confident that the actual average salary of employees in Atlanta is between $56,811 and $66,483.90. Although the average of the samples of Atlanta salaries is over $2,000 above the average of the population salaries, because the average of these population salaries of $59,456.67 is well within the range we are confident that the average Atlanta salary is in, we're unable to determine if there's a difference. Notice I compared the confidence interval to the population. Okay, so I took the population standard, or the population mean, and I compared the population mean to the confidence interval. And I said, hey, it's inside that confidence interval, so we can't tell if there's a difference. And then mention the effect size. Furthermore, even if there was a difference, the difference would be so small that it would require use of statistical techniques to notice, or large sample sizes, or a large sample size to even notice the difference. And then if the results should be used in regards to the research question, these results were not able to indicate that there was a difference between the average salaries in Atlanta and the United States. Okay, so, and the nation. Okay. So that is how you do that. So I'd highly encourage you, take a look through this, make sure that you thoroughly understand everything that we did, and as long as you follow everything step by step, not only will you thoroughly understand how to do this, but you'll also get an A on this part of the project. So, let's see here.